Hello, hello, hello. Welcome back. Today is Tuesday, the 21st of 21st? Tuesday, the 21st of April. Today, I'm going to be doing a live solve. I'm going to wrap up what I was doing with the GCSE math series just to make sure there's one complete set of that. I would normally not be streaming on a Tuesday, but with the current tube strikes, it means I'm not going anywhere else. So anything I thought I was doing, I'm doing math instead. So I'm going to do much the same as what I did last time. Go through a full run, go through how to check your work, which I think is the most important thing for math, give it a quick mark, and then we can wrap up and get on with our days. So without too much ado, I think I'm just going to launch straight into it. Got the paper at the ready. I'll do just the window for now. Yeah. So just the window for now. If I need to bring out the calculator so that you can kind of see what keystrokes I'm making, I will do that. In fact, get that at the ready. Calculator ready to go just in case I need it. So let me bring this back. So yeah, that's on hand. Paper's good to go. I say let's just get into it. So question 1. 8 numbers written in order of size, where we've got 3 integers in the mix. The median is 10. Well, let's immediately look at, so there's 1, 2, 3, 4, 5, 6, 7, 8 numbers, which means the median is going to be the average of these middle two. So that means that 8 plus j over 2 is going to be equal to 10. So 8 plus j is equal to 20, and j is equal to 12. The mode of the 8 numbers is 18, which means we've got to have 2 18s right at the end there, so k is equal to 18. And the range of the 8 numbers is 13, which means that 18 minus h equals 13, which means that h is equal to 5. And those are h, j, and k. Right, so moving on to question 2. Oh, bother. Okay, so in the real thing, make sure you've got yourself a ruler. I don't think I can draw objectively straight lines on this, and I do not have a ruler to use on the thing. So I'm going to freehand this, but in the real thing, make sure you've got a ruler. So we've got to draw the line y equals 2. Well, that's going to be a straight line going across, just like this. The line x equals 6 is a straight line down on the line x equals 6. And then the line y equals x plus 1 will have a y-intercept of 1 and a gradient of 1, meaning for every 1 you go across, you go up 1. So it's going to go straight through the diagonals. I'm missing these already. Something like this. Ruler is obviously best. Label each line with the equation. So this is y equals x plus 1. This is x equals 6. And this one here is y equals 2. So then show by shading on the grid the region that satisfies all 3 of these inequalities. Well, we need y values bigger than 2. We need x values, which means it's above that line. We need x values smaller than 6. So we want to be to the left of this line. And we want y values beneath the line. So we want this region in between, where it's to the left of the x equals 6 line, above the y equals 2 line, and below this straight line. Hello, hello in the chat. Yeah, spontaneous. Well, I'm actually going live later as well with a physics live solve, but I'm going to announce that one a bit better. Today's just a bit spontaneous with the tube strikes. So label this region R. I did not do that. Nah, let me clear some space to actually fit in R. R. Perfect. So then question 3. Plane takes 9 hours and 36 minutes to fly from New Delhi to Perth. The plane flies at an average speed of 820 kilometers per hour. So we have to work out the total distance. Well, distance equals speed times time. So it's 820 kilometers per hour. Now we have to convert this into hours. So this will be 9 hours and 36 over 60 lots of an hour. So if I combine that on a calculator, 9 plus 36 over 60, I will get 48 over 5 hours. And that times 820 gives me 7872 kilometers. And in fact, did I? Yeah, I should write my HJK there. So H is 5. J was 12. And K was 18. So making sure on the GCSE paper to make good use of my answer lines. So 7872. Show that this is the case. Right. Well, this is turning things into improper fractions. So 7 times 2 is 14, plus 2 is 18. So that makes that 18 over 7. 9 times 3 is 27, plus 1 is 28. And a lot of people would think, oh, let's multiply 18 by 28. Not so. You can cancel this. 2 and 1 over there. And these are both divisible by 7. So we divide top and bottom by 7. Turn that into 1 and that into a 4. Equals 8 over 1 equals 8. So here on question 5, we have a triangle. This immediately looks like, hello in the chat. This immediately looks like SOHCAHTOA. So work out the value of x. This is going to be, we have an angle, and relative to this angle, we have the opposite and the hypotenuse. So we have opposite and hypotenuse, that's sine. So sine 34 equals x over 6.5, which means that x is equal to 6.5 sine 34, which if we run it in the calculator, with degrees, that would give us 3.6 to 1 decimal place. So let me just scroll across so we can get that put in. Right, so change a speed of w meters per second into a speed in kilometers per hour. Okay. So we have w meters. So in 1 second, we have w meters. Now 1 hour is equal to 60 times 60, which is 3,600 seconds. So in 3,600 seconds, we have 3,600 w meters. So therefore, in 1 hour, we have 3.6 w kilometers, because we take this thing and we divide it by 1,000 to convert it into kilometers. So it's 3.6 w. Here, we've got a shape. This looks like a fun shape. So we have the perpendicular height is h, CD is parallel to AF, and the area is 390. Six-sided shape, work out the value of h. Huh. Okay, so AF is 21, CD is 15. Well, I'm thinking if we just draw these on, oh no, what I can do instead, that is probably a little more complicated. Let's split this up into a trapezium and a rectangle, because typically with these compound areas for GCSE, we're just combining 2 simple geometric shapes. So we know that that's 13 by 21. So we can work out the area of the rectangle with relative ease as being 273. Which means that 390 minus the 273 means we're left with 117 centimeters squared left for the area of this trapezium. Now, the area of a trapezium, you get that at the top here, I believe, in the formula book. Maybe. Yes, here, area of a trapezium is a half So in other words, it's the average of the parallel sides times the distance in between them. And so if we come back down to the question and apply that here, we've got 117 is equal to the average of the parallel sides. So it's a half of 15 on the top is parallel to 21 on the bottom. So the average of the parallel sides times, now this height of the trapezium is going to be the h we want minus 13. And this is going to be the equation we use to work out h. So 15 plus 21 is 36, divided by 2 is 18. So it's 18h, and 18 times 13, so it's minus 234. 117 plus 234 is 351, which is 18h, divided by 18, and we get 19.5. So I'm going to submit that as the answer. Right, moving on to question 8. We have 600 bulbs in a garden of different types with a ratio. So this is a whole bunch of stuff. A lot of people would get put off here. If you're the sort of person who gets put off by a question like this with a bunch of information, just look for one thing you know how to execute. So here, I'm looking at this. It's 5 marks, so there's quite a lot to do. I'm looking at this, and I see immediately this ratio, which I'm very well trained how to do. So let's just take that down first. So 9 plus 2 plus 4 is 15. So there's 15 parts. And we have 600 bulbs split into those 15 parts. So 600 bulbs is 15 parts. So we divide by 15 and work out that there are 40 bulbs in one part. Okay. So that way we can work out exactly how many tulips we have, how many crocus we have, and how many daffodils we have. Because 9 times 40, and in fact, because this is GCSE as well, very much going to write out all the steps here. So 9 times, so 40 times 9 is 360 tulips. 40 times 4 is equal to 160 crocus. And 40 times 2 is 80 daffodil. Okay, so that's the first checkpoint. That's something I know I've been able to execute. So now, 45% of these tulips are for yellow flowers. And 5/8 of these crocus are for yellow flowers. And all 80 of these daffodils are for yellow flowers. So we have to work out 45%. So that's 45 over 100 times 360. Gets me the number of yellow tulips, which when I type in gets me 162. 5/8 of the 160 crocus gets me 100. So there are 162 yellow tulips. So we have the 162 plus the 100 yellow crocus plus the 80 yellow daffodils. So 162 plus 100 plus 80 gets us to 342 yellow bulbs. So 342 on the answer line. Right, next. Someone's investing 4,500 Karuna in a savings account for 4 years. We have 2.4% compound interest. Work out how much money at the end of 4 years. Right. Well, the first thing you've got to know is that when you have compound interest, there is a sort of multiplier, which is 1 plus p over 100. So in this case, that turns into 1 plus 2.4 over 100. Which is 1.024. Now what's going to happen is you're going to take the 4,500 you start with and multiply by the 1.024 all raised to the power of 4 because we're doing this for 4 years. So that would give us, when I type that all in, an answer of 4,947.8, which is 4,948 to the nearest koruna. So 4948 is my answer there. Moving on to question 10, solving simultaneous equations. You have two options here. You either have the substitution method or the elimination method. I much prefer the elimination method, but I will show you how you could do both. So for here, if I multiply this second equation by 2, you get 6x plus 10y is equal to 16. And then if I do the bottom equation minus the top one, 6x minus 6x is 0. 10y minus 4y is 6y. 16 minus 1 is 15. So then y is equal to 15 over 6, which simplifies to 5 over 2. And then if I plug that back into the top equation, I get that 6x plus 10 is equal to 1. So 6x is equal to minus 9, and x is equal to minus 3 over 2. So x is minus 3 over 2, and y is 5 over 2. I like keeping things in fractions. Fractions are very much your friend at GCSE. So here, factorizing in question 11, factorizing this quadratic, our target number is minus 22. And we need to look for factors of that add to 9. And that will be plus 11 and minus 2. Those two numbers multiply to minus 22 and add to 9. So when you factorize it, you get x plus 11, x minus 2. So then here, hence solve that thing equaling 0. Well, we have x plus 11, x minus 2 equaling 0. Now, how can you have two things multiply together and get 0 as an answer? Only if one of those things is equal to 0. So we either have x plus 11 equaling 0, which means that x is equal to minus 11, or x is equal to 2. And so those are your two answers. So here, x is equal to minus 11 or 2. And here, I don't think I put that on the answer line, that it was x plus 11, x minus 2. Okay. So now, question 12. Ali uses a fitness tracker to count the number of steps he walks each day for 7 days. We have the first. Now, a mean is a total, the sum over the total number. So for 4 days, if the mean is that, the total number over those 4 days is that times 4. So 11,800 times 4 gives me a total of 47,200 steps for those first 4 days. For the next 3 days, we have a new mean of 13,207. So that times 3, 13,207 times 3 is 39,621 as the total steps for those 3 days. So the total number of steps overall 7 days is what I get when I add these together. So 47,200 added onto that gives me a total of 86,821 steps over the 7 days. So the mean is that total of 86,821 all over 7, which gives me 12,403. And it also helps if you can develop a sense check for what you think they would be. So clearly, if the first for 4 days we average this, and the next 3 days we average this, which is higher, we'd expect the overall mean to be some number in between, and we do find that is the case. So here in question 13, this immediately is screaming, yep. Oh, cumulative frequency graph. Okay. Let me zoom out a bit. So here, a cumulative frequency graph tells you everything you've had up until that point. So between 0 and 10, we get 7. For 0 to 20, we add up these, and we get to 24. which is the 7 plus the 17. So if there are 24 up to 20, and then a further 18 to get up to 30, well, 24 plus 18 is 42. So now we've got 42 up to 30, and then the next group adds on a further 14. So there must be 56 up to a value of 40. We then add a further 10 on to get to 50 to bring me up to 66. And finally, we have a further 4 to get me up to 60, which brings me up to a total of 70. So now, drawing the cumulative frequency graph, there is 7 at 10. So at 10, we've made it up to 7, which is here. At 20, we've made it up to 24, which is here. At 30, we've made it up to 42, which is there. At 50, we've made it up to 66. Nope, I've missed 40. 40 is at 56, which is here. 50 gets me up to 66, which is there. And I've hit 70 by the time I get to 60. Now I expect on a cumulative frequency graph to have a very like S-shaped curve. So I've got to zoom out to get it all on the screen so I can draw it in one line. The cumulative frequency graph. Now this is going to be tricky with this kind of thing that I've got going on here, but let me try my best. Now this should ideally be drawn in one smooth, continuous line. That'll do. So it doesn't matter that it's a little bit wobbly, because and what you should never do is connect them up with a ruler with straight lines. So they expect it to be not perfect, and that's why this is an estimate for the interquartile range. So interquartile range, you want to work out what 1/4 is of the way through is. So a quarter of 70 is 17.5. So I want to track across 17.5. Now, again, this would ideally be done, this part would be done with a ruler. I'm going to track that down, and that gets me a value of 16.5. And then the upper quartile is going to be 3/4 of the way through the 70 values, which is 52.5. Now, 52.5, I would track across again. Ideally, this should be done with a ruler. And that brings me to, if I track that down, that's again kind of squarely between the squares as I've drawn it. So that brings me down to 37.5. And the interquartile range would be the 37.5 minus the 16.5. And that gets me 21. Now, in the mark scheme, you'll see there'll be a range of acceptable answers, and hopefully that is in there. Now, find an estimate for the number of teachers who travel more than 46 kilometers. I would take my ruler, I would track from 46, which is there, and then that track across to 62. So 62 people drive 46 kilometers or less. So 70 minus the 62 is 8 people who travel more than 46 kilometers. So here now, show that this thing can be written in some form. Well, this is just expanding brackets. My preference would actually be to not take the first two, but to take the second two and multiply those, because that'll be more complicated. And multiplying by 3y is going to be easier. Because these are multiplied, you can kind of multiply them in any order, which is why you're allowed to do that. But if you are more comfortable, you can multiply the first two first. So here, multiplying the second two together, we're going to use our FOIL. First, outside, inside, last. So the first, so that's going to be 3y into. The first terms give me 2y squared. The outside terms give me 14y. Inside terms give me plus 5y. And the outside last terms here give me 35. And now multiplying all of these by 3y, I get 6y cubed. 14 times 3 is 42, so that's plus 42y squared. Oh, sorry, I should have... Bad form on my part. I should simplify this first before multiplying the 3y in. So that's actually plus 19y plus 35. And then the 3y times the 2y squared gives me 6y cubed. The 3 times the 19 gives me 57. And 3 times 35 gives me 105. So it's written in that form. So 6, oh, there's no answer line, so I'll just leave it like that. And then this one, what I'm going to do, what am I going to do? Well, I'm going to do, let's do what I would do generally speaking, which is to bring these two to a common denominator. And in this case, that common denominator will be 20. So here I'm going to say, I have to multiply this whole thing by 4 on the top and the bottom to get 8x plus 12 all over 20. And the second one, I multiply top and bottom by 5, and I get 30x minus 25 all over 20. And that's equal to 163 over 100. So now combining these, I get 38x from the 30x plus the 8x. And then I have 12 minus 25 is minus 13. But again, my brain's not in the mood, so I'm just going to run that on the calculator to make sure I haven't done anything silly. And then we cross multiply, or although this is where I advise you not to cross multiply because it is actually easier. Okay, I'll show you a more the rigid method here is to cross multiply. So multiplying the 100 up to the left, we get 3800x minus 1300. Multiplying the 20 across, we get 163 times 20, which is 3260. We can add the 1300 across and get 3800x is equal to that thing plus 1300, which is 4560. And then x is equal to that, divide by 3800, which is 1.2, or 6 over 5. Now, my preferred way at this point would be to simply multiply the 100 across. Because if we do that, then you would get 100 over 20 times 38x minus 13 is equal to 163. So it ends up just being 5 times this thing, and you get smaller numbers. So you get straight to 190x minus, and 13 times 5 is 65, equals 163. So 190x is equal to 163 plus 65, which is 228. And if we divide that by 190, we once again get 6 over 5. So that's one thing you can do. If you're a more confident student, you can think about the number of ways you can solve it and see if you can come up with more efficient or elegant solution paths that kind of impress yourself or an examiner. So here, making G the subject, what I've got to do is first, let's square both sides to get rid of that. So we're going to slowly unwind everything. Now, the classic way of solving these is to multiply to get everything on one line. So when I do that, I'll get 11e squared plus 2e squared g is equal to 7g plus 5. Then we want to make g the subject, so we have to get all the g's on one side and everything else to the other. So if I subtract 7g across here, I'll get 2e squared g minus 7g equals, and then subtracting the 11e squared to the other side, I get 5 minus 11e squared. Factorizing out a g, you get 2e squared minus 7 is equal to 5 minus 11e squared. And then finally, we divide both sides to get the g by itself. Now, you may have rearranged it separately, and so you may get an answer of 11e squared minus 5 all over 7 minus 2e squared. These are both equivalent things, and so that is also completely correct. One of the classic things I would expect to see here in terms of execution errors is sign errors when you are bringing things across an equal sign. So just pay really close attention to that. So here, g is equal to 5 minus 11e squared all over 2e squared minus 7. Now here, quadratic inequalities. The way to do a quadratic inequality is to sketch the graph. And from looking at the graph, you can see where the graph is positive and where the graph is negative. So first thing we have to do for sketching a graph is to factorize it, which is why it says to show your work clearly. You do have the option, if you prefer, of using the quadratic equation here, which you can find on the formula sheet at the start of the paper. I'm going to try and factorize it just for a bit of fun. When there's a number in front of the x squared, you take that number and you multiply it by the number at the end. So 3 by 32 gives me 96. So my target number is minus 96. And I'm looking for factors that multiply to the minus 96 and add to the plus 4. I can immediately see straight away that's going to be plus 12 and minus 8. But if you can't see that right away, go through factor pairs. So 1 and 96, 2 and 48, 3 and 32, 4, what's 90? It's 4 and 24, 6 and 16, and then finally 8 and 12. And then 8 and 12 is the one that gets you, when it's plus 12 and minus 8, that's the one that gets you to your 4. So if in doubt, all the factor pairs. Now that means I can do 3y squared plus 12y minus 8y minus 32 equals 0. Well, bigger than 0. Factorize in pairs. So this is 3y into y plus 4. And then we can take out a minus 4 here. Nope, minus an 8 here to get a y plus 4. And the reason why I kind of did that is I know these brackets have to be the same, which is why I didn't take out a 4, I took out an 8. So then I'm left with 3y minus 8 times y plus 4 is bigger than 0, which would give me values of y equals 8 over 3 and y equals minus 4 would be my values that give me exactly 0. So if I sketch this, y equals minus 4, y equals 8 over 3. Now we want where this graph is bigger than 0. So we want this guy and we want this guy. So in other words, we want these values of y. So we want the y's to be less than minus 4, or we want the y's to be bigger than 8 over 3. And that is how we're going to make this inequality work. So those are my answers. Y is less than minus 4, or y is bigger than 8 over 3. Okay, so we're getting into the slightly more tricky end of this. Question 16. Oh, I love Venn diagrams. Yes! So, 60 art students, 10 workshops, complete the Venn diagram. So 9 chose all of them. So 9 goes in the middle. Now it would be very tempting if I'm just going to zoom out so you can kind of see it all. This 17 chose knitting and photography. A lot of people would be tempted to write 17 in here, but that would not be correct because that 17 is everything in knitting and photography, including these 9 that we've already put in the middle. So there's actually 8 left to put in this region up here. And I'm going to tick them off to say that I've made use of that information because there's a lot to do here. So 16 are photography and embroidery. 9 have already been placed, which means there's 7 less left to place in that region. 20 chose knitting and embroidery, and 9 have already been placed. So there's 11 left to place in there. 28 chose photography in total. But you can see that 9 plus 8 plus 7 gives me 24. So there's 4 left to place in photography. 39 chose embroidery. And you can see that 27 have already been placed. So we have 12 left to put in embroidery. 2 chose none, so they're on the outside. And finally, there are 60 students in total. So if I add up all the numbers, I should get 60. But currently, if I add up all the numbers already placed, I get 53. So that leaves me with 7 left to put in K only. So one of the students is chosen at random. Given that this student chose photography. So out of these guys who chose photography, so out of these 28 people who chose photography, so out of these 28, how many also chose knitting? 17 did. So 17 chose knitting and photography. Out of the people who took photography in total. Now this n here in the front means not the probability, but the number. So find the number of people who did photography and not knitting. So here, photography and not knitting, that's these two. If you want a rigid method to do this, my advice, if we're trying to do photography and not knitting, or photography intersection, not knitting, the way the underlining method would work here, you underline anything in P, you underline anything in not knitting, and because these are the two that have been double underlined, these are the ones we want to include. So the answer is 11, because there's 7 people here and 2 people there. The answer is not 2. The answer is 11. By the way, if they wanted union, you would add together anything that's underlined at all. So I'm going to erase those. So if I were using the underlining method, I would be doing this in pencil, something nice and erasable. And then moving on to part D, find the number of, I'm going to write this down. So it's P union E. And that thing is intersected with K. Well, first, let's find out what P union E is using the underlining method. Underline everything in P. Underline everything in E. So the union will just be all of these guys. So in fact, I'm going to get rid of these double underline, and these are all of the elements that are included in P union E. And now this region is going to be intersected with K. So let me underline everything in K. And I can see because it's an intersection, I want everything that's double underlined, and that will be these 3 here. So 11 plus 9 is 20, plus 8 is 28. And so the number in there is 28 total. Moving on to question 17. So we have a proportionality question. As soon as I see this, I'm like, free marks, let's go, because it's such a rigid method. Q is directly proportional to the root of D, which means Q is equal to K times root D. And we can plug these numbers in to find the value of K. So 4.5 equals K times root of 324, and the root of 324 is 18. So K is equal to 4.5 over 18. Sorry, 4.5 over 18. Nope, typed it in wrong, and that gives you a quarter. Now plugging that in here, that means that Q is equal to a quarter times the square root of D, which is the final answer. Moving on to question 18. So we have a straight line. The gradient of the straight line perpendicular to P. So in order to do that, I know that the perpendicular gradient is minus 1 over m of the original. But to find out the gradient of the original, I need to get it into the form y equals mx plus c. So here, 5y is equal to minus 2x plus 7, and y is equal to minus 2/5 x plus 7/5, which means that the gradient of the straight line P is minus 2/5. So therefore, the perpendicular gradient, 1 over means you take the reciprocal, which means you flip the fraction, and then multiplying by minus 1 changes the sign. So it would be 5 over 2. Flip it, change the sign. Okay, now here, question 19 Some immediate context clues I'm seeing are that these are correct to a certain number of decimal places. So even if they didn't tell me this was lower bound, I'm immediately thinking this is a bounds question. So we want to work out the lower bound for the value of g. So we want the smallest possible number divided by the biggest possible number. And the biggest thing I can get on the bottom is for maximum f minus minimum h. So we want minimum c, maximum f, and minimum h. Let's separately work out what's happening with these guys, right? So for c, this is going to be on the interval. What you always do is you take one more level of precision. So I would take that, I would make that 8.0, and then you subtract 5 in that decimal place that you've added. So 8.0 plus 0.5 gets me up to 8.5. 8.0 minus 0.5 gets me to 7.5. So that's that interval. For f, we're going to add one decimal place to make it 6.620, and it's that 0 that we're going to add or subtract the 5 and turn it into 6.615 up to 6.625. And I'll show you a slightly, if that way I've been explaining it doesn't make sense, I'll show you another way to do it here on h. So if you, sometimes I add this, so let's add the 0 there. Turn that into a 5 would be the upper limit. And the number right before the 0, just subtract a 1 from that. So 2 minus 1 is 1, which would make that 1.15. So if I use that method here, or in other words, just add a 0.5 at the end, and that's the upper limit, and then subtract 1 from that number you added the 0.5 to. 8 turns into 7. That's the lower limit. Add a 5 to the end. Take the old final number and is the upper limit. Take the old final number 2, subtract 1, and that's the lower limit. So subtract 1 from this number at the end, add a 5 to both. These are your limits. So depending on how you like it, there's different ways of explaining it, but hopefully this makes sense how you take your limits for the bounds. So now we've worked out what these bounds are for c, f, and h. We can just plug in the values that we need. So c min is 7.5. 2 times f max, well, the maximum f was 6.625. Minus 3 lots of the minimum h, which was 1.15. So 7.5 all over 2 times 6.625 minus 3 times 1.15. So that gives me a value of 75 over 98. And I want my answer correct to 3 decimal places. So 0.765 to 3 dp. So 0.765 will go on the answer line. It's always best to write the answer on the number line because it just makes it easier to mark, even if you've already got it in the body of the question. So now from question 20, this is where I would expect to see things to get a little bit harder and to separate the 8s from the 9s. Or the 7s from the 8s, depending on how easy the paper is before that. But looking at this, I think we still got a ways to go. So let's see. So here, given these two things, express this thing and that thing. All right. Weird. Okay, so we want to write it all in terms of y. Okay. So 5k over x plus 2. Well, I can substitute what the k is. So that's 5x minus y over x plus 2, which is 5x minus 5y all over x plus 2. And now we can substitute in for x. So that's 5 into 1 over 4y minus 5y all over 1 over 4y plus 2. Now what I'm going to do is, in order to get rid of this, I'm going to multiply the top and the bottom by 4y. When I multiply every... is that the best way to explain it for GCSE? No, I'll tell you how I would probably do this if I were in GCSE. I would probably take them separately. So I think I would take the top as being 5 over 4y minus 5y. And again, bring these to a common denominator. So the second one, I need to multiply top and the bottom by 4y. So that's 5 minus 20y squared all over 4y. And the bottom, I would call 1 over 4y plus 2. So that's 1 plus, and that's going to turn into 8y over 4y. So I'm going to do that. And then to do top minus bottom, we use the keep, change, flip method. So 5 minus 20y squared all over 4y. So that's the keep. Change it to a multiply. Flip that into 4y all over 1 plus 8y. And the 4y's cancel, and you just get 5 minus 20y squared all over 1 plus 8y. Is this in the form they wanted? Yes, it is. So 5 minus 20y, in fact, let me do it like this. 5 minus 20y squared all over 1 plus 8y. Nope. Illiterate. 1 plus 8y. Okay. Now, in case you were curious about the other method, what I could have done from that point is multiplied top and bottom by 4y. So if I multiply the top by 4y, I'll get 5. And then this returns into the minus 20y. And you can kind of just get there directly. So multiply this term by 4y, I get 1. Multiply that by 4y, I get 8y. So that is faster if you're comfortable. But if you can't spot that, if you're not as confident with the algebra, you are allowed to split it out, do whatever work you need to do, and bring them back together again. Here on question 21, we see a little bit of geometry. I'm disappointed not to get a good circle theorems question yet. So we have a square and a circle. The total area of the shaded region is 80. Work out the length of AC. Curious. Okay, so, well, I can immediately see if I draw on AC, that is going to be the hypotenuse of this right angle triangle. And because this is a square, in fact, we can even, that would be radius. So the length of AB is the length across here, which is the diameter. So AB is going to be twice the radius, and BC is going to be twice the radius. And by Pythagoras, AC is the root of AB squared plus BC squared, which is the root of 4r squared plus 4r squared, which is the root of 8r squared. So if we can work out the radius, we can work out the length of AC. And the way we're going to do that is by doing this area. So the area that is shaded is the area of the square minus the area of the circle. So the area of the square is AB times BC. So it's 2r times 2r is the area of the square. And the area of the circle is pi r squared, and that equals 80. So 4r squared minus pi r squared equals 80. And we can take an r squared out of that and then get a result that r squared is equal to 80 over 4 minus pi. Now that r squared can go into the length of AC. So we saw that AC is the root of 8r squared. And if I plug that in here, it's 8 times 80 over 4 minus pi. In other words, it's the root of 640 over 4 minus pi, which I can type straight into my calculator and get a value of 640 over 4 minus pi is 27.3 to 3 significant figures. 27.3. Okay, question 22. The straight line has equation this, the curve has equation this. Where do they intersect? They intersect, so this is simultaneous equations. Those points of intersection are simultaneously solutions to both equations. So this is a quadratic simultaneous equation. What we do here is we take, let's take the x, because that will be easier to multiply by the 2. Let's rearrange this and say that x is equal to 5 minus y, and that will be substituted in. So we have 2 into x squared plus 3y squared equals 210. So that will be 2 into, now when I multiply this out, square the first, square the last, and twice, well, I'll do it in full in case you need it. So first is 25, outside is minus 5y, inside is minus 5y, last terms would give me plus y squared. So in other words, it's 25 minus 10y plus y squared. Now, if you're confident with your algebra at this stage of the paper, another way you can do that is square the first, square the last, twice the middle 2. So square the first, 5 squared is 25. Square the last, minus y. If you square that, you get plus y squared. And twice the middle 2. 5 times minus y is minus 5y. Multiply that by 2, you get your minus 10y. So that will go into here. And then we've got our 3y squared, and that equals 210. So now multiplying the 2 through, we have 50 minus 20y plus 2y squared plus 3y squared equals 210, which means that 5y squared minus 20y plus 50 is equal to 210. We can move this is a quadratic, so the quadratic has to be set equal to 0. So 50 minus 210 is minus 160 equals 0. And we can divide everything by 5. So 160 divided by 5 is 32. So immediately I can see that this will be y plus, nope, it's going to be y minus 8, which I want to be first for some reason. So y minus 8, y plus 4 is equal to 0. And then y is equal to 8, or y is equal to minus 4. Now, remembering right back at the beginning, x is equal to 5 minus y. So if y is equal to 8, x is equal to minus 3. And if y is equal to minus 4, then x is equal to 9. So the solutions are 9 minus 4 and minus 3, 8. Okay, so those are my answers there. Right. Oh, this looks ugly. Oh, I'm going to use this to make sure people know their power laws. That's fun. All right, then. So what do I see here? What I see here is that there's lots of factors of 5 and there's factors of 2 and 3. So 6, there's some 6s involved. Interesting. Right, let's pick off chunks of this one by one. So 30 I can write as 6 times 5. 25 I can write in terms of 5 as being 5 squared to the 2x plus 7. Now down here, root 180. I know I can simplify that surd because I can immediately see that is, at the very least, well, root 180 is the root of, I know that's 9 times 20. So in other words, that's root 9 times root 20, which is 3 root 20. But root 20 is 4 times 5, or rather 20 is 4 times 5. So root 20 is root 4 times root 5, and root 4 is 2. So multiplying that all through, I get 6 root 5 on the bottom. And that's times, and now I know root 5 is 5 to the half. And that's all to the 4x plus 9. Okay, so first thing, now the first thing's, okay, so the 6's are going to cancel. Now everything is in terms of just 5. So first thing I'm going to do is use my power laws to deal with these second brackets. So on the top, it's going to be 5 times. Now, the power law is reminding yourself that x to the a, all raised to the power of b, you multiply the powers together. So this will become 5 to the 4x plus 14. And on the bottom, we have root 5 is again 5 to the half. And then that becomes 5, multiplying the half in. Half times 4x is 2x. Half times 9 is plus 9 over 2. Okay. Now, the other power law here is x to the a times x to the b. You add the powers together. So 5 to the 1 times 5 to the 4x plus 14, that top becomes 5 to the 4x plus 15. And on the bottom here, again, we're going to add these powers together, and we're going to get 5 to the 2x plus 9 over 2 plus a half. 9 over 2 plus 1 over 2 is 10 over 2, which is 5. And finally, we use the power law that x to the a all over x to the b is equal to x to the a minus b. So we can subtract these powers and get final answer of 5. 4x minus 2x is 2x. 15 minus 5 is 10. And that is my final answer. So it's 5 to the 2x plus 10. So you can see that nice systematic working is the way through this. Get as far as you can, even if you can't get to the end, demonstrate what you can do. So maybe you can even just simplify the surd and then move on. I would expect at least one method mark for that. So rather than get put off entirely, see what you can accomplish. We have a vectors question here on 24. So we have our quadrilateral with our known vectors. Find AC. Now, with vectors, my way of doing this is with a good, clear pathing before you do anything. Do not attempt to do these things in your head. I highly recommend a good path first. So here, how do I get from A to C using known vectors? Well, I'm going to go from A to O, and then O to B, and then B to C. So I'm going to go A to O, and then O to B, and then B to C. Now that I have my good, clear path, I can substitute in and find out what that is. So to go A to O, I go against this arrow, so that becomes minus 4A. I go along from O to B, so that's plus 3B. And then I go along B to C, so that's plus 2A plus B. And then I simplify all that, and I get minus 2A plus 4B. So that's minus 2A plus 4B. There. Point P lies on AC such that it splits it into 3 to 2. So in other words, that's 3/5 and that's 2/5 of AC. Now, OPQ and BCQ, OPQ and BCQ are straight lines. So in other words, what they've done, oh no, I've missed that entirely. Again, best done with a ruler, but you kind of carry that on a straight line, and you carry that on a straight line, and you get to this point Q. So OPQ and BCQ are straight lines. Using a vector method, find OQ in terms of A and B. Now I expect, no, there is a 25. This is complicated for GCSE. In fact, I wouldn't expect this to show up in something except for iGCSE. So if you're normal GCSE, this may not be on your syllabus. But if you are iGCSE, the way to do this is to find the same vector by two different paths, one along each of the lines that intersect at Q. So what do I mean by that? I mean, let's find OQ first as being just direct from O to Q, because the two paths that intersect are OQ and BQ. Now, because this is a straight line, we know that OQ is parallel to OB, and to be parallel to something in vectors means that the vectors are multiples of each other. So it means OQ is some multiple of OP, which I'll say it's K lots of OP, for instance. And my other path from O to Q is going to be the other line, which is BQ. So I'm going to go O to B and then B to Q. Now again, BCQ is a straight line, which means that BQ is parallel to BC, which means it is some multiple of BC. So I'm going to write that in now in my path. So it's OB plus some multiple, I'll call n lots of BC. So now we have to find OP. So OP is O to A and then A to P. So why don't I find that first? So OP is OA plus AP. Now OA is 4A. AP is 3/5 of the AC we just calculated. So it's 3/5 of minus 2A plus 4B. Which we can simplify. So it's 4A's minus 6 over 5A's. So 4 minus 6 over 5 is 14 over 5 lots of A. And then we have plus 12 over 15 lots of B. And that is what OP is. So if I put that in here, it's K lots of the 14 over 5A plus the 12 over 5B, which gives me 14/5 K lots of A and 12/5 K lots of B. Now coming over onto the second pathing, OB we saw is equal to 3B plus n lots of BC, which is 2A plus B. So if we expand this bracket out, we get 2n lots of A and n lots of B. And then if we group them by the A's and the B's, that's 2n lots of A and 3 plus n lots of B by taking the B out as a common factor. Now, because these are both vectors for OQ, they have to be the same vector, which means the A parts and the B parts have to be identical. So what that means is that 14 over 5K is equal to 2n, and 12 over 5K is equal to 3 plus n. And from this, we can do simultaneous equations to work out n and k. So here we can say that n is equal to 7 over 5k from dividing both sides by 2, and we can plug that in here using a substitution method. So moving this across to the other side, 12/5 k minus 7/5 k is 5/5 k, which is just k. So k is equal to 3, and n is equal to 21 over 5. Now, the k equaling 3 is clearly the easier number to work with. So when finding OQ, I'm going to take the one with k in it. So therefore, OQ, which was 14 over 5k lots of A and 12 over 5k lots of B, when I plug k equals 3 back in, I'm going to get 3 times 14 is 42. So 42 over 5A. And then here, 12 times 3 is 36, plus 36 over 5 lots of B. So that was complicated. That's very much for the people going for the 9s. And here, finally, I think this is the final question. Yes. So final question here. This is a transformation of trig graphs, where you need to understand what these graph transformations do to the original sinusoidal curves. So here, let's think about what the original sine curve would have been. So the original sine curve would have had a maximum at 90 degrees and a value of 1. Now, what's going to happen here? Well, the 2, and then we're sort of transforming it. So the x plus 60 moves everything to the left by 60, and the 2 multiplies all the y values by 2. So I would expect this to be 30, which is 90 minus 60, and then 2, which is 1 times 2. So 30 and 2. Find the coordinates of point B. Well, that is the point that would have been 360 and 0. So that has been moved to the left by 60 to bring it to 300. And the 0 has been multiplied by 2 to give me 0 again. So that brings us to the end. Now begins the checking phase. So first thing to check is I have actually answered every part of every question. Easier than you think to not. So I have answers, that's answered, 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 yep, 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 yes, 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 yes. So far, so good. Not seeing any problems. Okay. Every answer line, when available, has things written in it, which I like to see. And then we will quickly get into the phase where I get the calculator out and show you the best ways of checking your work. Also going over any alternate solution paths that you might need. So OQ, I didn't write that down, so let's make that. Okay, so 42 over 5 lots of A and 36 over 5 lots of B. Okay, great. So every part of every question has been answered. Now I'm going to stop and I'm going to get the entire screen shared so that I can drag the calculator across as required, because I love the checking phase. Now remember, when you're checking, the best thing you can do is to rearrange the equation in a form that gets you 0, so you can just plug your answer back in, get your 0, and then you know it's right. This one, let's take our answers as given and see if these things are correct. Here, if j is equal to 12, the average of that would be 8 plus 12 all over 2, which is 10. Good. If those are both 18, then the mode is 18. If h is 5, then 18 minus 5 is 13. So I think this is correct. Here, I think this is correct. This is kind of just knowledge points. So I'm not going to spend too much time on this. Let's think of a way of doing this again. So if I have, so speed is equal to distance over time. Oh, this is good, actually. Let me demonstrate this. So speed equals distance over time. So time equals distance over speed. So let me do the distance I got divided by the speed, and that gets me my time in hours. Now you see this button here is very helpful when dealing with time, because it converts your decimals into hours and minutes. So that is 9 hours and 36 minutes, which is the correct time. So I know this is correct. Very handy button, that. Show that that is the case. Well, we know that's the case, and I did show it correctly by getting the improper fractions there and simplifying down. And to show that, so I already knew it was correct. Here I got an answer of 3.6. So in fact, what I'll do there, so it's true that that's how SOHCAHTOA works. So sine 34 is opposite over hypotenuse. What I'm going to do is rearrange that, and I'm going to do sine Sine 34 minus my answer of 3.6 over 65, and I should get something close to 0, which I do. So that is correct. What I'm going to do here is to choose a suitable value of W and make sure it works. So if I have 3, so let's say W is 17.1. Solve a GCSE O-level O-level paper. I didn't even know that O-level still existed. So let's say I pick 17.1. Let's see if I can plug this in and get my 17.1 back. So 3.6 times that is that many kilometers per hour. So if I multiply it by 1,000, it's that many meters per hour. And if I divide by 3,600, I should get meters per second, which is my 17.1 back. So this is correct. Now on question 7, what we're going to do is we're going to use my answer of h to work out the area and confirm it's 390. So if h is equal to 19.5, then if I subtract 13 from that, that should give me, this as being 6.5, and this is being 13. So if I bring the calculator back, that would be the average of these parallel sides. So 21 plus 15 all over 2 times 6.5. And I'm going to add on to that 13 times 21. I do get an area of 390, and that convinces me I'm correct. Here, this one is one where you kind of just got to redo it. So adding them together is 15 parts. So 600 divided by that gives me 40. So there's 40 bulbs per part. Multiply that by 9 is 360, times 4 is 160. Let me add these together and just confirm I get my 600. So there's always things you can do just to check you haven't made small errors on the way. So yep, those do add up to the 600 they're supposed to. 45% of the tulip buds does give me my 162. 5/8 of the 160 crocus does give me the 100. So 62 and the 100 and the 80. So 162 plus 100 plus 80 does give me the 342 I said. Okay, so that seems okay. This, you kind of just, yeah, this is redoing it just to make sure. So 4,500 times 1 plus 2.4 all over 100 raised to the power of 4. Yes, which is 49/48 to the nearest unit. Solve these simultaneous equations. This should be easy. We just plug them back into both equations and show that they work. So here, if I kind of uncross that out, so if I say 6 lots of minus 3 over 2 plus 4 lots of 5 over 2, that gets me 1, which is good. And then 3 lots of minus 3 over 2 plus 5 lots of 5 over 2 does get me 8. So I know for a fact those are correct. Factorize this thing. Well, I'll do this thing minus my factorized form with some random number, 59.82. So I'll do answer squared plus 9 answer. Oops, sorry, not helpful. You're not seeing me put my buttons in. Minus 22. And I'm going to subtract off this factorized form. So answer plus 11 answer -2. I should get a clean 0, which I do, so I'm correct. Hence solve this equation. Well, let's just plug in both answers. So answer squared plus 9 answer minus 22 should give me 0, which it does. 2 equals. Answer squared plus 9 answer minus 22 equals 0, which it does. Okay, so here, I'm saying the mean is this. To be honest, this I'm quite confident with. So this total over the first 4 days, this is kind of just rechecking. So that times 4 is that. 13,207 times 3 is that. That plus the 47,200 is the total number of steps. Divide by 7, that is the average. I'm confident with this. This I'm also confident with, that I didn't mess up the numbers, but I'll just check it. So 7 plus 17 is 24. Good. Plus the 18 is 42. Good. Plus the 14 is 56. Good. Plus the 10, 66. Plus the 4, 70. All good. Have I sketched it correctly then? I think I have. So it's 7, 24, 42, 56, 66, 70. That's all good. Interquartile range, way I did that, 0.25 times 70 gives me the lower quartile position, 17.5, which is what I found. 3/4 of the way through the 70 gave me my upper quartile position of 52.5, which I found. And I found these correctly, and that range is 21. And from 46, I do believe that is 62, which means 8 people did more than that. So I'm happy with this, and I can move on. This show that. I'm going to do the same thing as before. I'm going to take the form that I had, subtract off the form that I turned it into, and make sure I get a clean 0. So here, let's put in, I don't know, 482.57, for instance. I'm going to say 3 answer, 2 answer plus 5, answer plus 7, minus 6 answer cubed, minus, because I have to subtract all this off, so minus 57. That was meant to be a y squared. You see, good catch. This is why we check our work. And 3y times that should have been a y. So you see, this is why you check. So that should have been answer squared and minus 105. Well, let's say I hadn't done that, right? Let's say I hadn't clocked that. Let's say I kept it as 57 answer and minus 105. Look, I get something huge. I don't get 0, so that tells me I definitely would have got it wrong. That tells me to take a closer look. So I take a closer look. I see I forgot to multiply the y onto those terms. Cool, let's try it again. So it should work with any number, so I'll just keep that answer. So this time, 3 answer into 2 answer plus 5 into answer plus 7. And this time I'm going to knock off the proper stuff. 6 answer cubed minus 57 answer squared minus 105 answer. Oh, I didn't get a clean 0. Why not? I actually thought that was going to work that time. So I'd done something else wrong. So what did I do wrong? So 2y squared plus 14y plus 5y, and 14 and 5 gives me 19, plus 5 times 7 is 35. So 3 times 2 is 6. 3 times 19 is, nope. 3 times 19 is 57, and 3 times 35 is 105. So that felt like it should have worked. Okay, here's what I'm going to do. Maybe it was a bracketing issue. So 3 answer, 2y, 2 answer plus 5, answer plus 7, minus 6 answer cubed, minus 57 answer squared, minus 105 answer. Clean 0. Okay, that's good. So that's what you got. This is what checking is, right? Make sure you get to the bottom of what's not working in y. So now I'm convinced that's correct, and I spotted that nice execution error. Solve this thing equaling that. Well, that's going to be simple enough. I'm just going to plug my answers in. So I said x is equal to 6 over 5. So 2 answer plus 3 all over 5 plus 6 answer minus 5 all over 4. It does get me my 163 over 100, so I know that's correct. Make G the subject of this. Well, that's going to be simple enough. I'm going to pick a random value of G, 64.2. I'm going to work out what E would be. So E would be root of 7 answer plus 5 all over 11 plus 2 answer. So I get a value, and then I'm going to plug that in to work. And hopefully if I plug that in, I should get my G back into here. So 5 minus 11 times that E squared all over 2E squared minus 7. And I should get my G back, which is 64.2. So I know this works. Solve this inequality. What I'll do is I'll make sure I got my signs the right way around. So let's pick a y just on the other side of that. So y less than that would be minus 4.1. Let's confirm if I plug that in, I get a number bigger than 0. So 3 answer squared plus 4 answer minus 32 is bigger than 0. Good. And here, something slightly bigger. So 8 over 3 is 2.6. So let's put in 2.7. So that's a number a little bit bigger. So 3 answers squared plus 4 answer minus 32 is bigger than 0. So I have got my signs the right way around. Good to go. And I'll plug both those in and make sure that actually does give me clean 0. So minus 4, if I plug that in, 3 answer squared plus 4 answer minus 32 does give me clean 0. 8 over 3, plug that in. 3 answer squared plus 4 answer minus 32. Good, clean 0. So I know these are correct. Use the Venn diagram. This, I'm pretty sure, is just making sure you did it right. So 9 and 8 gives me the 17. 9 and 7 gives me the 16. 9 and 11 gives me the 20. Let me check that. 8 plus 9 plus 7 plus 4 gives me my 28. Which it does. Embroidery is 11 plus 9 plus 7 plus 12, which is 39, which is correct. And let me confirm that these all add to 60. 9 and 7 and 12 does give me 60. Cool. So then out of given that they chose photography, find the probability that they also chose knitting. So out of the 28 photography, 17 also chose knitting, so it's 17 out of those 28. N of P intersection not K. So it's P and not K, that is these 11. P or E, and it's also K. That is these guys in the middle, so that is 28. So here, let me just check if I plug a quarter root of 324 in, I do get 4.5, which is good. And it's directly proportional to the root of D, which it is, so this looks okay. Here, the original gradient was minus 2 over 5. And minus 1 over answer does give me 5 over 2, so that gradient's okay. Here, working out the lower bound, that is just a case of repeating it. So we want the lower bound of G. So we want the minimum C, which was 7.5, all over 2 lots of the maximum F, 6.625. Minus the minimum H, 1.15, which is 0.6. Yeah, so this is one, there's not really any checking here special, you just kind of redo it. So this one, we're going to take example values. So we said this was 5 minus 20y squared all over 1 plus 8y. What I'm going to do here is to find, for instance, let's choose a random value of y. So when y is 67.14. What we could find is 1 over 4 answer is this thing. So that's my x value. K value would be equal to, well, let's write this in. So it's 25 over, what was that? It was 67.14 is my x. My k value would be that minus y. And then 5k all over x plus 2 should be equal to this thing. So if I subtract this thing with y's in it, so 20 times y squared all over 1 plus 8 times y, I should get a clean 0, which I do. So this is correct. Here for 21, work out the length of AC. So what I'll do is I'll take my AC as given. No, this kind of feels like I want to rerun it. Or rather, let me say, okay, so if my R is correct, if my R is the root of 80 all over 4 minus pi, then it is that. So that is R. If that is R, then 2R times 2R is the area of the square, minus pi times R squared does give me 80, so that is R. And if that is R, then I'll put that back in and get, again, the root of 80 all over 4 minus pi being R. So I'm going to double that up for being the length of the square. Then the root of that squared for AB squared plus that squared for BC squared gives me this is the length of AC, which is correct. Okay. So here, find the coordinates. This is going to be really simple to verify. Let's just plug them back in. So if I have, let's confirm, first of all, that if I add them together, I get 5. So 8 plus minus 3 is 5. Minus 4 plus 9 is 5. I'll even, yep, that's 5. Minus 4 plus 9 is 5. So they both lie on the line. Let's make sure they both lie on the curve. So if x is equal to -3, in fact, let me put the results closer so I can zoom in a little bit. So I said -3, 8, and I said 9 minus 4. So let's zoom in a little bit and show you how you would plug in to here to make sure they lie on that curve. So here, 2 lots of -3. And you can see these are the easiest to verify. This is just plug your answer back in. So let's say you had limited time. Let's say you don't have time to check every single answer. The first thing I would do is check these algebra things where you can just plug your answer back in and know with certainty that you're correct. So 2 times 9 squared plus 3 times -4 squared is 210. So right, they both lie on both lines, so that is the answer. That is guaranteed, correct? Simplify this thing. So I said it was 5 to the 2x plus 10. What I'm going to do is plug in a value of x and get a clean 0. So, well, in fact, I've already got an answer in of 210. Why don't I plug that in? So, no, it's a little bit too far. This will be fine. So if I have that answer, I'm going to do 30 times, in fact, this may be too much for my calculator to take, but maybe not. All over, because the number was 210, so that's big, times root 5. Nope, that should be on the outside. So root 5 to the 4 answer plus 9. And that thing, minus 5 to the 2 answer plus 10 should give me clean 0. Math error because I tried to make it go too high. So let's take 3.57, for instance, instead. So instead, 30. Now, the reason why that happened is because you tried to go over like 10 to the 100, which your calculator just breaks. So I'm keeping the numbers small but random. So if I'm in any way wrong, this should give me a really ugly number. So times root 5 all to the power of 4 answer plus 9. And I'm going to subtract off from that 5 to the 2 answer plus 10. I should get a clean 0, which I don't. Because I did the answer to the bollocks. It's because I did answer, not 2 answer plus 10. Okay. Take 2. 6.94. Nope. 3.94. Nope. 3.94. Guys, I'm so good at pressing buttons. All right, take 3. And this is another reason to check, by the way, is because it is easier than you think to just mispress something. So 2 answer plus 7. Root 180 times root 5 to the 4 answer plus 9. And if you subtract off from that, 5 to the 2 answer plus 10, clean 0? No. Why not? Did I get this wrong? Yeah, no, it's because I put the square root over everything down there. All right, take 3. Ugh. But calculator skills, right? It's surprisingly easy to just... This is why I don't like calculators. It's because... Okay, so it's 180. All right, let me come out of that to make sure it's times the root of 5 all to the 4 answer plus 9. Subtract off from that 5 to the 2 answer plus 10. Come on, clean 0. Math error. Let's go. Why? Oh man. Let me just take 0.84. Last one, I swear to God, this has to work. Maybe it's just asking for numbers that were too big. So 25 to the 2 answer plus 7. Maybe the math error is because I'm trying to use an answer function in the power. So root 5, but I was getting answers before using this technique. So 4 answer plus 9. We're going to subtract off from this 5 to the 2 answer plus 10. Clean 0! Finally got there! Yes! Oh man, I'm so bad at calculators, guys. All right. But that means that is correct. Find AC. I like the way I did that. It was A to O, and then to B, and then to C. So minus 4A plus 3B plus that. Simplify, minus 2A plus 4B. That looks good. The checking on this is just kind of redoing it. One thing you can do to check, though, here is to confirm that the same thing works if I had plugged the n into this other guy. So 2 times this guy is 42 over 5, and 3 plus 21 over 5 also gets me my 36 over 5, so that looks pretty good. So it works the same for the k or the n. So I'm going to leave that just because there's nothing really that simple to verify there. And I'm pretty satisfied with this. What I'll do is I'll plug in my answers and confirm that I do get my y value out. So 2 sine of 30 plus 60 does give me 2. And 2 sine of 300 plus 60 does give me 0. So those 2 points do lie on the curve, and I'm satisfied there. So right, with that in mind, now we are going to check. So I'm glad I did check because I did catch one execution error in there. So let's rearrange my things just to get the mark scheme on the page as well. Zoom out a little bit so I can see my answers. And then zoom in a little bit on the mark scheme so that you can see what it says. And let's just run down the line. I'm just going to quickly scan it, not do a huge deep dive. Here, 5, 12, 18, good. Yep, that looks all good. 78, 72, yep. What's this? Yeah, they want to see all the steps there. I did the cancellation method, which is I think by far the easiest way of doing this. Good. Here, the next one, 3.6, good. 3.6W, good. 19.5, 342. But you can see, even if you don't get the answer right, look at, there's method marks available for doing each little bit. So even if you can only do a little chunk of it, it's very worth putting it on the paper. So 49, 48, good. Minus 3 over 2, 5 over 2, good. X plus 11, x minus 2, 2 and minus 11. Good. Let me do one extra little zoom in just to make it look better on your screens. All good. 12,400 and hold on. Whoop. Zoom across. 12,403. Good. So 7, 24, 42, 56, 66, 70. Good. It's kind of hard to use the overlay. I'm guessing they have like a set one and you have to put it on top and make sure it works. I'm just going to say, yeah, so something between 18 and 22. Yeah, I got 21 and I got 8 for that. So I'm going to say I got that right. Here. 6y cubed. Yeah, only the GCSE papers. I've done a couple, right? I just want to put the GCSE papers out there for anyone who needs it. I've got a couple of GCSE students, and I think demonstrating good checking technique is the way forward. These are the only 2 I'm going to do. I'm then going to go back to A-level papers, but I think it's worth putting that out there in case there's people out there who need it. So I got this right. 6 over 5, 1.2 correct. Yeah, 5 minus 11e squared. Yeah, that's correct. Y is less than 4 or bigger than 8 over 3. Good. start this Venn diagram. 7, 8, 4, 11, 9, 7, 12, 2. Good, good, good. Then 17 out of 28. 11, 28, all good. A quarter root D. 5 over 2. 0.765. 5 minus 20y squared over 1 plus 8y. 27.3. 9 minus 4 and minus 3, 8. 5 to the 2x plus 10. Minus 2a plus 4b. This was complicated, but I got it. 42 over 5 and 36 over 5b. And finally, 32 and 300, 0. All good. So it's good that, in fact, let me close those down so I can drag you across and have a good look at you. So yeah, it's a good, that proves why it's important to do your checking, right? I knew how to expand that algebra, and yet I still made a slight execution error, got something wrong, and wasn't going to get the marks I deserved until I checked it properly. So finding ways to plug answers back in to get a good clean 0 is the best way to check and the quickest way to check to make sure you've got something right, unless you're like me and can't press buttons very well, but in which case just practice it. And that's something I would do as you're doing your runs. As you're doing your timed runs, make sure you have enough time. And with the time you have left before time is up, think about how to check your work. What is the easiest ones you can go in and check and confirm for yourself you know you've got them right, because then you can walk out of the paper feeling good and confident, like, yeah, I got a bunch of marks there. I'm feeling like I did a good job. So that's really why I wanted to do this GCSE run, was to give you good demonstrations of those checking skills. So now that you have those, hopefully you can put those into place throughout the rest of your run. And in the meantime, I'm going to dip myself back into the A-level syllabus, do a few more runs of some A-level papers, and some of the the physics content as well. In fact, I think I'm going live this evening with a physics seminar for those who can make it. So yeah, in the meantime, have a good rest of your exam season, GCSE students, and I will see you when you're ready for A-levels. Unless this ends up doing wildly successful, in which case maybe there's a use case for me to do some bit more GCSE stuff. If you want that to happen, do YouTube-y things. I know you know what to do. But in the meantime, I'm going to let you get back to it. All right, I will see you guys next time. Take care. Bye-bye.